Anyway, thanks for having me. Perfect day to come to Chicago, obviously. So I'm going to give you just a really kind of broad overview of what I call digital psychometrics. So this is basically a term that I've made up. It's not clearly defined at all. I define it basically as everything that is in this presentation. I'm happy to talk about it later on to see if there might be like a better way of doing that. So I just want to start by saying that a lot of the stuff that I'm going to talk about is not actually my work. I would love to take credit for it, but it's coming out of the University of Cambridge Psychometrics Center. So I'm now at Columbia University, but before that I was in Cambridge at the Psychometrics Center. So this is a bunch of colleagues, postdocs, PhDs, and they were heavily involved in all of the work that I'm going to present. Okay, so just starting with traditional psychometrics, and we've already heard quite a lot about this. That's what a usual questionnaire looks like, if it's nicely done. If it's not nicely done, you probably just have a page with multiple statements and like your usual rating scale. But it's really kind of trying to get at people's self-perception. So how do people perceive themselves and describe themselves as it relates to their psychological characteristics? We've also already heard a lot about like the downsides of self-report questionnaires. One is certainly being like, sometimes you might want to present yourself in a slightly better light than who you actually are, especially if the stakes are high. So if you're interviewing for a job, you're probably not going to say strongly agree to a question that says, how much do you agree with the statement, I make a mess of things. But there's also kind of all kinds of biases where people might not even intentionally misrepresent, but it's just like limitation of memory. Could be affected by a mood, reference group effects is something that we've already talked about. I'm also not saying that we should get rid of questionnaires altogether. I think that's something that I usually tell people working in companies. So when I work with kind of people in recruiting, is like, yes, it might be great to kind of bring in new measures, something like predicting personality from digital footprints, whatever it is, but it's actually people involved, right? So, and people love to express themselves and they love to feel in control. So if we were to get rid of questionnaires altogether, we're actually risking hurting the experience that people have going through these processes. So instead of saying, let's get rid of self-report questionnaires, my attempt is more saying that can we complement them with something that gives us a different perspective on people's personality, psychological characteristics that overcome some of these limitations here. Okay, so what do I mean by digital psychometrics? The idea is basically that we're going away from asking people about their self-perception and we're looking at what they actually do. Like, what is it that they actually do as they go about their everyday lives? And that's a whole bunch of things. So that could be anything from what do they say on Facebook, what do they like on Facebook, what kind of movies are they interested in, what do they buy with their credit card, or even what do they do with a smartphone, right? Because like most of us, I think I looked it up this morning, and it's about, in the US, it's about 98% of people, especially in the group of millennials, like the generation of, I think, 35 now and under, has a smartphone that we carry around with us pretty much all day. We have it next to us pretty much all night. So there's just a lot of data that's being captured about us on a very kind of fine-grained and granular basis. And the idea is that what we're trying to do is, can we take that data that's being captured about people's behaviors, preferences, to actually learn something about people's psychology? So not just looking at behaviors and kind of trying to predict like future behavior, but looking into ways of extracting insights from that data that tells us about something about people's psychological traits. Okay, and what we know is that, and I think that was actually one of the main findings when my colleagues at Cambridge started, that they were extremely surprised by, is that pretty much anything they tried to predict was predictable. Obviously with different degrees of accuracy, but pretty much anything they tried in terms of outcome variables, so whether that's personality, values, ability, cognitive styles, and any type of input, so that could be Facebook likes, Facebook status updates, Twitter, credit card spending, was kind of predictive of these outcome measures. So it's very likely that if you were kind of to pick a new one, let's say you wanted to look at people's browsing histories, or what they kind of post on Instagram, and you pick one of these other psychological measures, that you would find some kind of relationship there. Again, might not be super accurate, but there might be relationships. Okay, so what I'm going to talk about, well, definitely in the first half of the next 45 minutes, is something that was set up by my colleagues at the Psychometrics Center in Cambridge. And it's a database that we've been working with extensively. And what I think is most interesting about it is that it's open source for researchers. So if you have a research question that you're interested in, and I'm going to show you in a second what the data looks like, then you can actually just go to this website, complete like a really short form of what you want to do, just to make sure that people are not abusing the data in a way that we think is not ethical. And then you can actually get hold of that data. And what it was, so the way that the data was collected was basically, it was a Facebook app that was set up, I think, 2007. So that's when apps on Facebook all started. And it allowed people to take real psychometric tests. So kind of they could take a personality test, they could take an ability test, and that were validated and kind of gave scientifically proven feedback. And that was the only incentive for people to actually take those tests, was get feedback about themselves and learn something about their kind of psychological profiles. And people love getting feedback so much that it went viral on Facebook, and he ended up collecting data of more than 7 million people around the world. It's questionable if you were to do that again, if it might work the same way, simply because there's now so many things on Facebook. I guess, like for those of you using Facebook, you all know the not so scientific quizzes of which Star Wars character are you. Just give us access to your likes and we're going to tell you a whole lot about your Star Wars profile. But back in the day, it was fairly new and people loved it so much that they just basically shared it. So there was like no financial incentive for people to complete it other than getting feedback about themselves. So on this one side, we have a whole bunch of psychometric tests, like the standard ones, like the big 5 personality, values, life satisfaction, again, IQ, impulsivity. If you go to my personality website, you'll see the full list of measures that we have. What makes it interesting for us is that basically for half the people, we also have their Facebook profiles. So once people had received feedback on their personality, they were asked whether they would voluntarily share their Facebook profile. So they didn't have to, they got the feedback no matter what, but it was just like saying, if you want, you can share your Facebook profile with us for research purposes. And you can see about half the people did so. Question is whether they were not really aware of what they were doing back in the day, so that's, yeah. But again, it was kind of with user consent that we kind of got this Facebook data. And what's interesting is now, so this is Facebook, like how many of you are on Facebook? Just quick raise of hand. Or is there anyone who doesn't know anything about Facebook? Okay, we're going to talk about that. Don't you worry. It's okay. So Facebook likes is just, there's actually different types of Facebook likes, and I'm just going to talk about people liking official Facebook pages. So for example,
what do you think about the characteristics of these samples? I mean, who is on Facebook? Who is answering your survey? Who is?
Yeah.
I mean, do you have any way to get baseline information?
Yeah. So we have demographics, age, gender. It's slightly younger than the general population. Gender is fairly balanced. It's actually, like obviously it's not perfectly representative, but it's close. And the good thing about, like if you really cared about like a representative sample, because we have so many people, it's pretty easy to stratify. So even in the group of like, let's say men between 70 and 80, there's going to be probably like 10,000.
But I bet if you did it now, it would switch, because I think like my mom is the only one who's still answering these surveys. You know what I'm saying? So I think if you put it out there, you could beef up that.
No, that's true. Like Facebook itself is actually getting older. So the youngsters are now using Snapchat and whatnot. But again, like overall, it's fairly representative. And if you really wanted to do, you could stratify it and get it to
I'm just talking in
representative.
terms of like income and race and things like that.
Yeah, so we don't have much information on that.
I would guess really poor people if you don't have they're not on the, you're saying everybody is still nonetheless caring.
Well, I guess like what you see is that, for example, openness is slightly higher than the average, because it's usually people who are curious and want to learn about themselves. So in that sense, assuming that openness is correlated with like higher socioeconomic status,
Can't you extract income in these things anyways? If you can essentially extract values and stuff, why not? I mean, you should be able to narrow down. If you have a full-blown footprint, so to say, you should at least, be able to calculate brackets, right? Income,
Or location, at least, like where they live. Yeah.
location.
if we collect locations, so I mean, what this app was trying to do is collect the least amount of information possible that's still valuable for research purposes. But technically, you could do it in a sense that you're making assumptions. I think that's actually one of the reasons why most of the time, at least in the context of marketing and business, people haven't really used psychological traits that much, because at some point to make these predictions, even if it's then data-driven, you need both of these sides. So in order to say, I predict values from Facebook likes, I at some point need a data set that gives me both. Because I need to be able to train my model for likes with some kind of gold standard, which at the moment is still self-report. So if I had income for those people, which we have in a different data set, so we could technically do it. But for those people, we just didn't collect it, which means that it wasn't really possible to build models to predict it for the whole sample. You could make assumptions. I mean, Facebook actually has this, it's actually an amazing research tool also. They have like this audience insight, which everybody can get access to, like basically everybody can access. It's open source. And what you can do is you can say, what's the profile of people living in a very specific area who like Lady Gaga, for example, and who are kind of leaning more towards the conservative political party. And then they give you like a whole bunch of descriptive statistics about income, about gender distribution. So if you were not interested in individuals, but kind of segments, you could actually do that. Yeah. But this is really the key in, like right now at least. So pretty much everything that I'm going to talk about is basically taking people's self-report as the gold standard that we're trying to predict. It's also kind of questionable if that's the best way of doing it, because as I said in the beginning, self-reports have limitations. I think one of the good things in this context is that there was technically no incentive to cheat and to lie, because the only thing they got was feedback. So if they cheated on the test, they were basically destroying the whole value of the thing that they just did. But again, at some point, we might actually develop new personality models that are purely behavior-driven. But what I'm going to talk about today is really this idea, we have an outcome, and we're trying to see if we can predict the self-reported scores just by looking at people's behaviors. Okay, so one of the footprints that I want to kind of focus on for the start, because that's where most of the research has been done coming out of the Psychometrics Center, and I think that's also some of the research that's been blown up most in the media recently, is Facebook likes. So again, in this context, so what you can do on Facebook is like your friend posts something or posts like a funny cat video and you like it. That's not what I'm talking about. So I'm only talking about the official Facebook pages. So again, Lady Gaga might have an official Facebook page, the BBC, CNN, like all the kind of people who say, okay, I'm going to establish an official Facebook page and people can like that. And to start with, I just really want to show you a few very simple examples of how personality can be related to some of these digital footprints, in this case, Facebook likes. Because I think oftentimes people are fairly skeptical about the machine learning predictions and approaches, because it's not always easy to see what's happening behind the scenes. But what you're going to see in a second is that oftentimes the face value, like the face validity that these predictions have are really high. So those, for example, are the Facebook likes that are most strongly correlated with extraversion and introversion. So again, this is mainly talking about the big five here. And you can see it kind of makes sense. Extraversion are like the outgoing, like cheerleading, Jägermeister, sunbathing. This is kind of a little bit gendered here. That's probably not controlling for age and gender. And then we have introversion on the other side. It's all things that are kind of much more introspective, kind of much more quiet. You don't really have to interact with other people.
So wait, what aspect of Facebook are you using? You're not looking at likes or are you?
Those are just Facebook likes.
Just,
yeah.
okay, no, before you were saying you were going to look only at certain sites. Okay, fine.
No, so those are just...
This is just likes, sort of randomly sampled.
It's likes of pages. So it's not if one of your friends posts something and you like it, and that wouldn't count as a like. That's just liking a Facebook page. So that shows up in your profile. It's basically you've liked 20 pages or something like this.
Is this in one country or is this like...
Oh, this is the US.
Just the US?
Jägermeister?
Yeah, Jägermeister. US? No, this is actually only US data. Yeah. Yeah. Which means that they're probably also like a lot more international. What you see with extraversion is that it's highly correlated with travel and drinking, I guess, also.
Let's say for a UK sample, the items would be very different.
Interestingly, so in some of my studies, I actually use, that's more in the context of marketing, but I just extract likes from a US sample, use them in the UK, and they work in a very similar fashion. So UK, US seem to be fairly similar. Obviously, if you go to another country, it becomes very different.
Perhaps the activities might be similar, but I don't think cheerleading would be very popular in the UK, right?
It's probably not popular. So those are not the most popular ones. Those are the ones that are most predictive. But if, like, let's say in the UK, you like cheerleading, you're probably even more extroverted than someone in the US. So in that sense, those are just the ones that are, like, it doesn't say anything about how popular are they.
People.
There are two people, yeah. But interestingly, again, like if you
I'm not sure about the external validity of that.
Yeah, if we've tested it, and again, like if it's Western cultures like Australia, Canada, the US, and the UK, the models are pretty kind of robust across those cultures. If you go to, I don't know, Germany, France, then you just don't have enough likes that are overlapping to get these models that are robust. Yes.
You talked about the surveys and the answers given by the participants, but you didn't talk about the likes in itself. Do you assume that the likes are true preferences, or is like in Jägermeister in itself like a show-off behavior of a certain
social display?
Yeah,
Everything is.
So I'm just interested in your view on this. Do you take this as a true preference or as a...
I think, like, if you go to Facebook, everything that's social is usually kind of just making you look a little bit better than what your life probably looks like in reality. There's like an empirical answer to that. So actually people tested whether your Facebook profile reflects your actual personality or your like idealized personality. What they find is that it's closer to your actual personality. And one of the things, so I think what we see is like this just self-enhancement that everybody does, and there might be kind of different levels. The thing is with like social media is that it's still a social context, right? So if you suddenly kind of like things that your friends know you have absolutely no interest in, they're going to call you out. So like one thing is that this social context makes you want to self-enhance, but it also kind of puts a little bit of control over what you do. And if you go overboard, it actually might hurt you instead of helping you. That's a good question, yes.
So there's a page called cheerleading.
Yes.
And so how many, these 8 pop up out of how many total pages?
There's like tons of pages. So I think in the models that we've used, like definitely hundreds and thousands. So we're usually working with pages that are liked by at least 10 or 50 people. And that still gives you a matrix of like 60,000 columns or so.
And these pages are the ones that are most discriminating with respect to extroversion.
So those are the pages, yeah. Mm-hmm.
I would say a methodological question.
Mm-hmm.
So how do you derive these? Is this like they have the highest individual correlations with the trait you're interested in, or is this combinations?
So those are just individual correlations. Later on when we're going
because
to...
they could be, could be very different people, right? That if you think about predicting a subject, then so suppose someone is not into Jägermeister at all, but is extroverted. So how representative is the combination of these 5 items?
Of these 5 items, so like you're probably not going to find anyone who has all of them. But in the end, for the model, it doesn't really matter, right? It's just like if you think about it in terms of like even just a linear regression, each of them would just get a weight. If you have liked it, you kind of get bumped up on extroversion. If you haven't liked it, nothing happens. If you like one of the introverted ones, you kind of get scored down in terms of. So this one,
You'd have a lot
not.
of missing data if you were running that regression, right? Looking at individuals.
I mean, that's why.
No, that's why you're using the pairwise correlation.
So right now, I just wanted to show, basically, you can even take the average personality profile of everybody who kind of likes sunbathing to get this. What we're doing later, and I'm kind of going to get to that at some point, is that if you want to, just like a little hint, no, if you want to predict personality at the individual level, because the matrix is so sparse, like you have like 60,000 likes, and each person on average has like 230, which is already quite a lot. That's why you bring in machine learning, because that's when your linear regression is probably going to fail.
But you're always going to end up with this. These are low popularity pages, right?
Well,
So
low. Define low popularity. There's a
the average popularity or average number of likes. Let's say popularity is defined by the number of likes on the page.
Yeah.
So your extremes are always going to be a low popularity thing. It's just by, it's going to be kind of it's a methodological artifact.
Yeah, like the ones that are, because if it's like liked by everybody, you're just going to be ending up somewhere average, but they still have like a couple of thousand people liking them. Like even within our data set of, let's say, 50,000 people that we're looking at for the purpose of these studies. So like we're excluding everything that has less than, I think in the things that I'm going to show you, less than 50 likes. So kind of to get rid of this.
So how did you skew the one? Say, for example, some pages, if you go to a very popular company pages at Google, probably has millions of likes.
Yeah.
So how did you normalize that again? I don't know how many likes on this page. PC magazine, I can see. Manga, I don't know what it is. So.
So you're probably on the extroverted side.
So I'm just wondering, how did you normalize those? Like we say thousands of likes, right? That's very, very small.
Yeah, like what happened?
What millions of likes? I somehow have 20 millions of likes.
Yeah, but it doesn't, like, if you kind of take that into account in like predicting the individual person, it doesn't really matter. Right. And what just happens with like likes that everybody likes, they don't become predictive. So what the model would do is just kind of discard them as information. So they're not going to be predictive because if everybody likes Google, that means all extroverts are liking Google, all introverts are liking Google. So there's nothing that we can extract from that like in terms of learning something about the personality profile. But we're coming.
Roughly, what's the question? What's the distribution of likes across? You've got a minimum of 50. You probably have a maximum of the entire sample or something.
Yeah.
So I mean, just roughly, what's the distribution?
I mean, it's definitely skewed to the left. So basically, most of the likes have like low frequency, and then you have like a whole bunch that have like, well, a couple of thousands is actually quite common in this data set. Sometimes you have millions. Like if we go to Shakira, Lady Gaga, like the big artists, you get like a couple of millions. Okay, so just to move on. Oh, this is like psychologists love quizzes, or at least I do. I love quizzes. So this is one of the big 5 traits for those of you who are familiar with the big 5 traits. And again, it's just like the high and the low end of one of the big 5 traits.
There's a page I don't read.
I don't read. I know. That's actually very, very predictive. Openness. Yeah. So this is. I mean, that's one of the most obvious ones, I guess, like low openness, I don't read, the Bachelor Teen Mom. And again, this is just showing that, I mean, there's some likes that you have no idea why would they relate to extroversion, like just doesn't make any sense, but for most of the time, they actually have pretty good face validity. Another one, also like a big 5 trait. There's only 3 left, so you have a fairly good chance of getting it right. Could be extroversion on this side, yeah. It's in this case not. Neuroticism, yeah. So I think in this case it's like emo. Sometimes I hate myself is like an indication of the neurotic side. And I think these ones, well, this is like, is that right? Yeah. So skydiving and climbing are probably things that if you're highly neurotic, you might not want to do because it's probably just going to freak you out. So if you want to do that, you probably have to be fairly emotionally stable. Okay. Physics. So now we're actually coming to the prediction part. And I wasn't really sure how familiar people were with like the idea of machine learning, cross-validation. So I'm just going to walk you through the steps of how we would get from this matrix of basically having people's self-reported personality. So we have like each user gets its own row. They have like a personality score in all of the 5 traits. And on the other side, we have like the personality, right? So in this case, again, we're just talking about Facebook likes. And what you would get here is, so this one is much wider because we have 1 like per column. So that just means user 1 has liked running, user 2 hasn't liked running, and then you just get all of the likes on the right-hand side. Now there's different things that you can do. Because this matrix is so wide and sparse, there's like ways of reducing dimensionality using PCA, SVD. There's also machine learning algorithms that can actually take account of the sparsity without having to reduce it first. So I think that's what they used. So this is the Yo-Yo paper. In this case, they used lasso, which is a pretty standard machine learning technique where you don't necessarily have to reduce dimensionality before because it's not exactly the same as stepwise regression, but it's basically trying to get rid of the variables that are not predictive in any way and kind of reducing complexity in this sense. So basically, you really have those 2 matrices, like the self-reported personality plus what is that those people like. And then you can start building models. So in the same way that you kind of build your linear regression by having an outcome and several predictors, you do the same thing, like having the personality as an outcome, using the likes as predictors, and you build the model. Now the thing is that because we want to be sure that we're not just overfitting the model on the data that we have, we usually do out-of-sample predictions, and what's most common is like a 10-fold cross-validation, which just means that of your original data set, you take 90% of the participants, you build the model, and then you take for the last 10% of the participants that you haven't used in any way to build the model, you just take their Facebook likes, so you're ignoring their self-reported personality, you're just taking their Facebook likes, you're running it through the model, and you're getting the computer-based prediction of what their extraversion looks like, their openness looks like, and for all of the other big 5 traits, right? So this is basically like the prediction that the computer makes that's not influenced by the data that you use to train the model. And you do that 10 times, so you always take 90% of the participants, then you take the second 90%, third, and you end up with a matrix of computer-based prediction across all of the big 5 traits. And now you can basically do what we do, like what would just be like a normal correlation. So you can take people's self-ratings on, let's say, openness across the board for all of the users that you have, and you compare it to the computer judgment. So how close are the computer-based predictions to people's actual self-reported personalities? Does that make sense? So it's basically just giving you a correlation of how much overlap is there between the way that people see themselves or describe themselves and the way that the computer would have predicted and their personality profile just by looking at their Facebook likes. Yes?
2 quick questions. I mean, the 90% of participants each time are randomly selected?
So it's always taking, let's say, if you divide the sample in 10 chunks, first time you would be taking the first 9 chunks, predict the last 10, and then you just go down. Yeah. They're not random, yeah. Mm-hmm.
And then the second one is, out of all the likes, do you choose them all? Do you put them all in?
Yeah.
They're all in.
Yeah. Uh-huh. So you put them all in, and that's why machine learning comes in handy, because you don't know which ones are going to be most predictive. And those algorithms can actually handle it. So instead of overfitting and not having enough input data for the number of cases that you have, those algorithms can handle it. If they can't, then you would kind of run a principal component analysis or some kind of dimensionality reduction measure.
Well,
so there's these 2 ways.
I mean, there are these questions about normalizing the scales of these variables.
Yeah, I mean, the thing
That's
with
a big issue with classical.
Yeah.
So I'm just wondering just how sensitive it is.
normalizing the scales on the personality side or the like side?
The like side.
I mean, the like
They're
side is...
the right-hand side. Those are the
Yeah.
predictors. Yeah, I'm just saying it is scale dependent. I mean, that's been one of the complaints against econometrics.
It's scale dependent in the sense, I mean, with likes, it's actually nice because you just have like ones and zeros. So you could technically normalize it across participants. You could normalize it across
So it's strictly
columns.
binary.
It doesn't really change much,
I
yeah.
see. No, of course, I see.
I mean, but my question was, in a sense, right? I mean, if you have thousands of these predictors,
Yeah.
and some of them, when they're all together, might have zero explanatory power,
Yeah.
and maybe that's why they're going to be dropped out by
Yeah.
the machine. They might actually not necessarily be, with zero power prediction. It's just that they are sort of, multicollinear with gazillions of other predictors. So
Yeah.
how do you then, or how does the machine at a certain point decides to drop them?
So that's so that's like
Is
a
it just
decision of
based on
how
the
much.
R-squared that they explain?
Yeah. So how much does it actually explain enough additional variance for it to be justified to be kept in the model? So that's the decision that the model makes. But you're right in the sense that, let's say this. Yeah. So that's kind of. I think it's kind of like at least in the lasso model. So it would definitely matter in regression and stepwise regression. I think the lasso model is pretty good at dealing with that. But it still means that, let's say, if we just take the overall sample, like one predictor doesn't, it's just being trapped because it doesn't add anything on top of something else, and you have a user that just happened to have like this one like, it could have been more predictive, however the model dropped it. In that case, it's bad luck in a way. If you had done like a dimensionality reduction, that might have helped a little bit because it might still be picked up by one of the topics or one of the components. But yeah, that's why. I mean, that's also one of the reasons why, and I'm going to show you the accuracies in just a second. Like at the level, they work very nicely at the aggregate level. At the level of the individual, you're always going to make tons of error. So if people ask me whether I would recommend using that to select candidates, not really. You might use it as like a filter and then have other steps in the selection process, but at the level of the individual, we're still not really at the level where we can be confident that we're actually making a good call. Yes?
But the performance is going to be different across the 10 models that you have.
Yeah.
Does that matter at all? Or all you care is a prediction and each of the 10 doing a good job?
Yeah. I mean, what you can do, for example, and actually that's one of the reasons why I like lasso, because it gives you coefficients similar to regression. If you kind of do neural nets, then it's just like this black box. And then you can see it, like look, for example, just at the standard deviations and see which ones are most consistent across the models. If you were to kind of implement such a model later on, so we have developed like our own little testing website where you can use it, you would just use the full model. Because then it doesn't really, you've kind of validated it, you know what is the accuracy, and then you would just go for the full data set. It's a good question.
You're
Yes?
always doing it on the whole sample, right?
You can,
It's always the whole sample, right? You could do a similar exercise, say, for predicting female versus male,
oh,
right? Or old versus young.
It's actually, yeah, I'm going to talk about that in a second when I,
Probably much better, right?
yeah.
I think.
So that's one of the things that we then tried in the latest stage. It's not published yet, it's a work in progress. If you have these tree-based classifiers, where you build separate models for, let's say, like gender, different age groups, you get higher accuracies, which makes sense because like the same like doesn't necessarily have to have the same meaning. Let's say, I don't know, like a 15-year-old girl likes Justin Bieber, probably a different signal than when like, I don't know, a 50-year-old guy likes Justin Bieber. Might be, it's like a different predictor or get a different weight. So that if you kind of, the more you break it down, the more you break it down in these kind of trees, the better the prediction becomes. Totally agree. Okay, so let's look at some of the accuracy estimates. And this is just, so again, this is the correlation between your self-report, like this not, like I'm going to get there in a second, but what we're looking at is the correlation between self-reported and computer-based, computer-predicted personality. And what we're usually trying to compare, because it's really difficult to say what is good, like how accurate is good enough. So one of the things that we're comparing it is to the retest reliability of a questionnaire. In this case, it's a short questionnaire, which would be like, even if you take the same test twice, right, you don't always get the same results. So that's the benchmark that we're setting for ourselves. And again, there might be different opinions on whether that's a good benchmark or not, but that's what we're using for now. So the first paper published in 2013, that used like a dimensionality reduction technique and then used just a linear regression approach to train the models. So those are all averages across the big 5 traits. So some traits are easier to predict. Openness, for example, is easier to predict. Extraversion is easier to predict. The trait that's, I think, the least predictable is agreeableness. But those are just averaged across all of the 5 traits. So you can see around 0.3 M5. The second paper that they published on pretty much the same data in 2015 was just using slightly more sophisticated machine learning algorithms. So that was using lasso without having this dimensionality reduction. And you can see like now this is already kind of bumped up to a correlation of 0.55. And if you think about it in terms of how much more variance is explained, this is actually like a pretty huge jump. And what she did, because I think it was like a very interesting idea, is that she kind of came up with a second measure of accuracy. And what she...
What's the correction for degrees of freedom? In the lasso, you're admitting many more possibilities. You're allowing these things to have in there, but they're small coefficients and the total prediction. So you're adding, you want to use something like an adjusted R-squared, wouldn't you?
It's like technically it's just a correlation. So we're not making a prediction, and
you're giving yourself many more predictors with the lasso type, right?
So
like
what
the principal component or something, you're getting like 3 or 4 predictors or however many components.
Yeah.
But here you're allowing the whole sample really to come in with maybe very small weights.
It is small weights, but what lasso does is basically, if it doesn't...
No, it has a threshold, I understand.
Yeah.
But it's generally adding many more regressors, that's all I'm saying. It still could keep in a lot of low weight regressors, right, that could pass the threshold.
Yeah, so in the end it doesn't really matter because the measure of accuracy that we're using is just how does the computer-based prediction compare to the self-report.
I'm just thinking you're using an awful lot of more variables with one procedure than the other, just comparing these two studies, right?
And how would that kind of influence the accuracy measure?
You keep adding regressors, you can get an R-squared of 1.
But that's the thing, because we're not looking at so we're not saying like what is the R-square of the model that we're doing. Right. So that's not the accuracy measure that we're using. We're saying let's make the prediction.
You are using some measure in the original sample, right? If I understand.
No, so we're saying like we're predicting the outcome. We're not looking. So the R-square you could just get from like running a regression, looking how much variance is explained in your sample, like within those things. What we're doing is we're predicting it, we're taking the prediction, and then we compare it to the self-report, and this is the correlation. So the correlation is not coming from your R-square within the model that you're training. The R-square correlation is coming from I'm predicting my outcome and I'm comparing it.
Training it with many more regressors is what I'm saying.
But it still doesn't affect the correlation that we're kind of having between the self-report measures and the predicted outcomes.
Giving yourself more predictors is really what I'm saying.
But the predictors, that's totally true. Like it's definitely more predictors, but it doesn't affect the way that we think about it.
If I have more predictors, even though I use a new sample, I'm still using more variables to predict. Anyway.
Yeah, but like you can't even, like the way that we measure accuracy is in no way related to the R-square that you would get from this model that you're training.
No,
is what
the
I'm
training
saying.
model still is you're adding a lot more regressors. Is all I'm saying.
I agree. Like in terms of but it's just adding more signal in a way to kind of get to these computer-based outcomes.
There's independence there.
Okay.
You're getting an independent draw, but you are still doing better.
Okay.
In some sense, on the first stage, anyway, small.
I'm with you. All good. Okay, so just coming back to this comparison of like how accurate is the computer, one of the things that she compared it to is the accuracy of people in our environment. Like, so, and that's one of the benefits of the My Personality dataset is that we not just only have self-reports, but we also have other reports. So we have like people's coworkers, people's friends, people's family members, and spouses rating the personality of the people that we're predicting personality for. So basically what we can say is, how many likes does the computer need to be better at predicting my personality than my colleague is? How many likes does the computer need to be better than my friend, again, my partner, my family? And what we see is, and looking back, so at the time of the study, the average number of Facebook likes per person was 230, which for the US is like average. I guess for other parts of the world, not quite, but it's actually constantly going up. So by now, the average number of likes is probably even higher than those 230. But a computer needs only 10 likes to be better than someone's work colleague. Needs about 65 likes to be better than someone's friend, who you would think actually should actually know us fairly well, because we're usually spending quite a bit of time with our friends. Needs about 120 to be better than one's family member. So on average, the computer is still better than someone's like sister, mother, father. Like we obviously can't really control who is kind of completing this questionnaire, but family member. And only when it comes to the spouse or partner, they perform slightly better on average than the computer. But again, if we're thinking that the number of Facebook likes are constantly going up, what you would expect is that by now the computer is probably as accurate as your spouse or partner, just by looking at your likes.
What's the baseline of this one? You say predicted better to compare to their own self-assessment?
Yeah, so that's the self-assessment. So we're basically saying, how does the person see themselves? How accurate is the how accurate is the like friend, spouse?
Okay, so how many likes to be with the self-assessment? What's a minimum number of likes you need to predict the closest to his self-assessment? Better than self. Not better than
You
self.
can't really say, I mean, that's the thing, like the only thing that you can get at if you want to see like better than oneself.
Similar, not better. It can't be better.
Like the more likes you have, the better. But you can predict it with like a fairly...
What's a minimum closer to, for example, you can compute the Cronbach's alpha, right? Almost like reliability. So like we predicted is how many number of minimum words you can reach. They say Cronbach's alpha is 0.8.
I mean, you can say how many likes do you need to get 0.5 correlation of...
How many,
And I think that's like 0.5 is the average, so about 250 to get to this 0.5, yes.
I may have 3 questions.
Okay, and then we're moving on because I'm not going to get there.
So one is, it could be better than self. That's the whole purpose of it ultimately, right? So you
Talking about that in a
so
second.
you could actually try to predict their behavior better than they would themselves, right? So that's one.
Coming.
The other is, why is, you said for some facets, the predictive power is better than for others. Is it because in these footprints, personality manifests itself differently for these different traits, or is it that these notions are better or worse defined in the first place? So
I think
prediction is more difficult?
I think that relates to the traits themselves. So extraversion is something that's just very expressive, right? So that's actually signaling to the outside world a lot more than something like neuroticism, for example. The same with openness. It's like music preferences, like everything, like books, music preferences are strongly related to openness. And those are like, a lot of the Facebook pages are kind of related to these preferences.
And my third question is, let's take this seriously, okay? And then, take what you said seriously. Then what you're telling us is this digital footprint is a manifestation of personality.
Mm-hmm.
Right? That's what your claim is. Now, why don't you do exactly the same exercise as the big five guys did, 100 years ago, 150 years ago, taking all the language verbs, say, and run a new factor analysis on all these, say, expressions, right?
Yeah.
And then come up with a new model of personality,
Impress.
which might outperform us. You know what I'm saying?
Yeah. So we actually did that with language. And so basically, in this case, we forced it to also give us like 5 factors because we just wanted. It doesn't really have to be 5. I think the big advantage of like some people say like, why do we even need personality? It doesn't make any sense. If we just want to predict behavior, why don't we just go from behavior to behavior? Like then we don't have these 2 prediction errors of kind of going through personality. If we like
even conceptually, right?
Yeah, but it just makes it a lot harder if you have like 20 dimensions to interpret them in any meaningful way. So that's why we said, okay, let's just limit it to 5. It could be 10. We've also done 10. It just becomes like the more dimensions you have, the harder it becomes to interpret them in a meaningful way. But that's exactly where it's heading. So we did that with status updates where we said, okay, let's just get rid of like our assumptions about self-reported personality, just let the data speak, so to say. And it's interesting because like even if you just cluster based on data, you still get these relations to the big 5 traits.
That's good news, right?
Yeah.
What's it? I mean,
Well, you're not surprised.
no.
I mean, it was
Big came out of
built on language, exactly.
And it was built on
Yeah.
Oh, sorry. Sure.
Yeah.
No, no.
You could
No,
do it
no,
on likes
no,
and
exactly.
yeah,
Likes,
mhm.
right?
Yeah.
Sorry. No.
yeah, likes are just much harder to interpret in a way. If you kind of have, let's say, 5, 10 factors.
It could be interesting. I mean,
It would
if
be-
it is an
yeah.
expression of personality, then
yeah.
Let the data
Yeah.
speak how many factors
Yeah.
there are, and then try to interpret them.
Yeah.
Give them a name like openness. I mean,
Yeah.
I don't know what.
I mean, it then the first factor that you'll see if you just let the data speak will be like a gender or a cultural factor. So then you would have to kind of tweak it a little bit to say like, okay, what are like actually beyond demographic variables? What are the dimensions that come out? But that's the same for exactly personality. Yeah, but totally right. So that's what we're kind of where we're moving towards. The difficulty is that it's not always easy to interpret, but totally agree with that. If we can just, yeah, I'm coming back to that. Just like in a few slides. Okay, so the latest one is actually, again, work in progress, something that we're currently working on. And what you see is that we're now getting really close to the retest reliability of the questionnaire. And there's a few things that we did here. One is actually using the tree-based model, saying that, okay, let's fit different models for gender and then split into different age groups so that we're not comparing oranges with apples, but we're just building a model for each of these subgroups. The second thing is that we use the likes to predict dislikes. So Facebook doesn't really have that option. You can't really dislike something, but you can make assumptions based on the data. So for example, if someone likes the Democrats, it's very, very unlikely that they like the Republicans too. And you can basically say, okay, so what if they had the chance to dislike something, what would it be? And if you use that information, that bumps up the predictive accuracy. And the last thing is that we didn't predict the overall score. So we didn't say, okay, let's predict extraversion, but we predicted the response to each individual item. So we kind of predicted what is that person going to respond to this question, and then let's score it in the way that we would usually score the questionnaire. So that's also helping to kind of get it a little bit more accurate. Yes?
Sorry, it's a very narrow question. There's a link, I think, in the Kaczynski paper or is in the UU paper where you can get your big five. It'll machine learn your Facebook and your Twitter.
Also coming. Like I think there's just way too much stuff coming. But
but I was just having been invested in this when
yeah.
the Kaczynski paper came out and he had the algorithm. I found it utterly unconvincing.
Yeah.
But the latest one, we redid it just a couple months ago, was actually pretty good.
Yeah, it's getting better. We still.
So you're actually the old links that go to what would have been the old survey or old system have been updated so that you're actually.
I think the one that we're currently using is the yo-yo, so we're not even using the latest ones. And I think it's coming. I'm just going to, do I have another 10 minutes, 15? I think so. No, I can also just be quick. Okay, so this is just correlations. Let's just skip that. What I'm showing is thinking about it in terms of psychometric properties. So split half reliability, so how consistent are those predictions internally if you just take half the likes and correlate it with the prediction of the other half. Again, doesn't have a consistency as high as the self-report measures, but it's fairly reliable. And now these are the things that's coming back to your question. So this is basically the correlation between our computer-based personality predictions and other variables that we have in the data set. So if we assume that openness should be correlated to a certain political ideology, which we probably don't have in here, but so this is just openness, and you can see okay, so those are basically correlations between self-reported openness and all of the things that we have here. And those are the correlations between the computer-based prediction of openness, and everything that's above the line would indicate that the computer is better at predicting external variables. Everything that's below the line would mean that the self-perception is better. And you can see that it's pretty similar. So it's not necessarily that they're better, but they're kind of getting at the same level of accuracy when it comes to predicting other stuff. Okay, the language-based predictions, I'm just going to skip because it's pretty much the same thing. I'm just going to show you a few examples that I think are interesting. So again, those are just which words are most highly correlated with these traits. has a pretty good face validity. Like extroverts talk about amazing party, weekend love. Introverts look very different. It's like computer, internet, anime, reading. So again, the behavior is pretty distinct, even if you're just counting words and looking at correlations. So this is the last quiz, I promise, but it's my favorite one. So again, one of the big 5 traits. They talk about family, friends, happy, agreeableness. Yeah, so those are the nice people, the less nice people. Some people might have seen it. It's I should have all blacked it out, but I like it a lot. And we're not cherry picking here. So those are really just the ones. Obviously, those are not the ones that come up with the highest frequency, but they're just most indicative of people being very competitive and critical. Not surprisingly.
Where are the words from? From
Facebook status update. So that's just stuff that you post about yourself for those people. Okay. Yes.
One question. It seems I noticed did you guys get rid of the functional words already?
The functional words, they should be in the prediction models.
And none of them is predictable?
So
saying the functional words here.
So I'm I think in this case, because that was the study that's coming out of Penn, so that's Andy Schwartz and Greg Park. I'm pretty sure they got rid of the functional words because I've seen their code. So what they do is they usually work with n-grams and topics when they make the predictions. This is actually something where you have the functional words. So this, the Luke dictionary, just gives you a whole bunch of variables about what is it that people talk about, functional words like pronouns and stuff. And there's situations in which the topics are actually more predictive and situations where linguistic style is more predictive. So in the context of work emails, for example, there's probably not that much variation in terms of topics, and then it becomes more interesting in terms of how people talk instead of what they talk about. I'm going to go over this. So this is the website I think that you were referring to. It's Apply Magic Sauce. It's still live. You can just log in with Facebook. I'll just show you a little demo and I'll stop it before we get to the end. But it's basically, you go to the website. It's hosted by the Psychometrics Center in Cambridge. So you basically give us consent to predict your profile. You'll have to log in with Facebook or Twitter. You can do both if you have both. So I'm already connected, which is why it's not kind of giving me this login window. So I connect with Facebook, and then click on Make a Prediction. It's I'm really slow, apparently. And it takes a few seconds, so it's kind of scraping your Facebook likes, status updates, and tweets. And then it turns it into a profile. So you can say, I just want to look at my likes, posts, and tweets. In this case, I just take all of the sources, predicts my age, predicts my psychological gender, which is kind of a little sad, but still 51, so on the right side. Big 5, leadership, IQ, life satisfaction. Again, it's certainly not perfectly accurate, but it might give you an idea and tell you what your online profile tells about your psychological profile. Okay, let's see if I can skip that. Okay, this is again a very quick foreshadowing, I think, of what's coming more and more in the next few years, is that we're going beyond these stable traits and we're looking at real-time assessment of psychological traits such as mood, state, personality, so how extroverted is someone in this specific situation, and that's because we have now a lot more of these wearable tech gadgets that a lot more people are using. This is, I think, probably most of you have seen this, the election of the Pope in 2005, election of the Pope in 2013. Everybody's just the way that we experience the world is just now mediated through these devices, right? So we talk to our friends over social media, we capture the moments that are most important to us through our phones. And this is all being captured in a way that actually social scientists can look at and make sense of behavioral habits and patterns. We know that, for example, we can predict depressive episodes by looking at people's Instagram pictures. Again, not super accurate, but it's better than not knowing anything about that person. We can also look at it or predict it from all the sensors that come with your phone when you buy it. So GPS, accelerometer data, so how much activity is there, how often do you call your friends. So if we see changes in the frequency with which you kind of make calls or get calls, or how often you leave your house, those are all kind of indicators that maybe you're entering a depressive phase. Interestingly, Facebook itself has been called out for doing research into this, which, I mean, this is probably my own perspective, but everything that comes up in the media is always entirely negative. So it's like, oh my God, Facebook is using like information about whether like a teenager is depressed or not to exploit them and manipulate them. If you think about it, if we had the chance to detect like when a child or teenager is entering a depressive episode, isn't that absolutely amazing? Because they're probably not going to go to their parents and tell them. If we have ways of kind of identifying those people at risk, obviously what we do with that information is like a completely different question. But if we have that opportunity, I think it's worth exploring. And this part I'm, again, also going to just glimpse over. But the idea is that oftentimes when we think about digital footprints, we think about stuff like Facebook, Instagram, but actually even playing something like and this is stuff that's, again, coming out of the Psychometrics Center, so it's a new, like a gamified version of mental rotation tasks or pattern completion tasks, and you can look at the way that people perform, so you can just basically see whether they got it correct or not. But what you can also do is look at all of the information, and this just is like a short selection of the variables that we have, like all the stuff that you capture about the behavior, the way that they play the game. So what we can do now is we can not just only look at the responses, but we can also look at how do they actually get to that response. So do they spend a lot of time walking around and kind of looking at it? And what is it that they actually do that can then help us make even better predictions? The data usually looks like something like this, which means that...
So what do you do with this data? You have all these different... So what are you going to crystallize from this?
So what you can do, for example, is look at the people that are most successful. Like, what are the strategies that they implement? So for example, in this one, which is like a mental rotation, which of the figures are the same, what you see is that people who, for example, jump on top are the more successful because they probably get like a different view. But again, that's something that you just have to get out of the data because it could be that, for example, people who spend a lot of time, they could either be the ones who are highly motivated, they kind of want to figure it out and want to be sure that they get it correct, or it could be the ones that are just like slower in getting to the correct answer.
But you were suggesting you could also infer strategies.
Yeah, so that's like, is it that, for example...
Not just that I jump on top, but I mean, that's kind of a fact, right? But kind of the sequence of decision making, or of probing, I guess.
I mean, I guess then it just becomes a question of timing. So then it's like which...
No, you can automate that. That's what I'm just asking, how you
What do you mean automate that?
Well,
like
you,
in
have
terms
these,
of the...
you have the sequences on each person. Then from those patterns, how do I come up with the notion of what are successful strategies?
Yeah.
What are the most important, which are the most successful, which are the common strategies?
Yeah, I mean, that's then like an empirical question, so you can look at the data that you can capture, and what's oftentimes the hardest part in like machine learning is to come up with meaningful features.
Right.
So that could be like, okay, do I want to look at whether people jump on top of something? Is it more about whether they look around and then jump on top? So that becomes a question of how many things can you actually think about that you might want to input into the model. And I guess in that sense, it makes sense to work with people who kind of develop general ability tests, because that's nothing that I really do. If you want to define the feature space in a meaningful way, if you have a theoretical idea of which strategies they might be applying, it definitely gives you a head start here.
A model of search, you could sort of apply a test.
Yeah.
No, I'm just, has it been applied?
This is like super new. So this is, again, like work at the very early stage of what we're currently doing. Okay, well, thank you so much. If you have any other questions, I guess I'll be around. Thanks for all the questions. It was super interesting. And sorry for running over.